Hello dear students. As you know that in our last classes we have started the discussion on diffraction and we have completed everything about the Fraunhofer diffraction in details. We have studied about the resolving power, particularly in the last class. Today we will start our discussion on Fresnel diffraction. As you know that the Fresnel diffraction actually when the source and the screen, so they are at finite distances, or any one of them is at finite distances from the obstacle or the aperture. So that is the Fresnel's diffraction. And Fresnel's diffraction is the actual diffraction that was noticed by the people long before, and that led to the explanation of that particular phenomena of light. So Fresnel diffraction-টাই প্রথম মানুষ দেখতে পেয়েছিল এবং যার ফলে এই সমস্ত এক্সপ্লানেশন ইত্যাদি দিয়ে আমরা ফেনোমেনাটাকে এক্সপ্লেন করার চেষ্টা করেছি. So it is the Fresnel's diffraction that was noticed by people long before, so nearly 300-400 years ago, and then Huygens, Fresnel's, this type of people, so they tried to explain the phenomena on some theoretical basis. So that's the Fresnel's diffraction. But later on it was the Fraunhofer diffraction. Fraunhofer diffraction was particularly designed to get the diffraction. So Fraunhofer diffraction হচ্ছে আমাদের একটা এক্সপেরিমেন্টাল অ্যারেঞ্জমেন্ট যেটা আমরা অ্যারেঞ্জ করেছিলাম. So Fraunhofer diffraction is a type of arrangement which we have arranged to get diffraction. মানে এটা তুমি বলতে পারো a type of forceful arrangement. You see that the source is at finite distance, but by some mechanism of using that lens and everything, we push it to the infinity. Similarly, after diffraction, the screen is at finite distance, screen to finite distance here, but by making some optical arrangements using convex lenses, putting the things in the focal plane, you just push it up to infinity. So that is how both the source and screen were at infinity, and those type of diffractions were easier to study. At least the mathematics of them was quite simple to study, and that is what we have done in our last classes. But now you will see that the things are not so simple, and that is because the wavefront will be now treated to be as some spherical cylindrical types of waves, because you know that diffraction from this finite when the source and the screen or any one of them are at finite distances, so finite distances, sources and wavefronts, they basically correspond to the realistic wavefronts, which is the spherical or the cylindrical wavefronts. And you know that when the wave comes from a long distance, যখন অনেক ডিসটেন্স থেকে আসে তখন আমরা যেটা করতে পারি, when the waves come from long distance, then a small portion of the spherical wavefront we take it to be some plane, or a small portion of the cylindrical wavefront we take it to be some plane wavefront. So that is the different issues, and plane wavefront treatments are particularly simple as we have already seen in our Fraunhofer class of diffraction. So আমরা দেখেছি আগে Fraunhofer class of diffraction এ যে plane waves যেখানে আছে, wherever there is plane waves, the things are simple to deal with because its amplitude is treated to be as constant. So amplitude টা constant থাকে, so সেটাকে ডিল করাটা আমাদের ক্ষেত্রে অনেকটা সহজ হয়ে যায়. And you know that the spherical waves are actually represented in this particular way, some a by r, and then there comes the e to the power I omega t minus kr. So you see that this one is a function of r, the amplitude. So this amplitude part, I call this one to be the amplitude. এটাকে amplitude part বলা হয়, এটাকে phase part বলে. So you see that the amplitude part is no longer a constant, but it is the function of a by r. So এখন এটা আর constant নেই, but এটা function of a by r আছে. And the way I understand is that this is your source, and suppose at a distance r, what will be the waves? So you see that the waves can propagate in any of the directions. Waves যে কোনো direction এটা চলে যেতে পারে. So r distance এ waves টা কোথায় থাকবে? The waves will lie on this sphere, and that is why I call this a spherical wavefront. So the wave will lie over here. So wave টা এখানটাতে lie করতে পারবে. So it will lie over here, the entire wave. So we may say that we normalize it by some factor, that how much is the contribution at this particular point. So at a particular point e kotota contribution hocche, so that one you may just normalize by some r, so a by r, because দেখো এখন একটা পয়েন্টে যে কন্ট্রিবিউশন হবে, ট্রাই টু আন্ডারস্ট্যান্ড ইন দিস পার্টিকুলার ওয়ে, ডোন্ট ট্রাই টু জাস্ট ম্যাচ আপ উইথ দ্য এক্সাক্টনেস. সো এক্সাক্টনেস এর সাথে ম্যাচ করুন, আমি জাস্ট তোমাকে বোঝানোর চেষ্টা করছি যে কেন এটা আর দিয়ে ডিভাইড করতে হয়. Why do we actually have to divide by r for the spherical waves? You will see that in this class I will not require this. Actually these treatments are quite difficult and it is not in your course directly. So এই ধরনের a by r wala treatment, the treatments consisting of a by r is a bit difficult, and these are not in your course right now. So এগুলো তোমার কোর্সে নেই, so we are not doing it. But still I will give you some idea, otherwise it will be an injustice to you that I have introduced the waves to you, I have introduced the spherical waves, but yet I did not explain to you that why this R actually comes into the picture. So it would be an injustice to you people, and that is what I don't want, and I want to give you some idea. So a choto idea dite to oshubidha nei, just 5 minutes of idea, so there is no issue in it, so there is no harm in it. So just try to learn it. Now you see that this distance, suppose it increases, so now the wave, suppose it is over this particular plane, so এখন এই প্লেনটাতে আছে, and this one is your RC. So now you see that the surface area has increased. So you may say that the contribution to a point has reduced. আগে দেখো তোমাকে ধরো আমি, so I have given you some 100 penny, 100 টাকা তোমায় দিয়েছি, 100 টাকা দিয়ে তোমাকে বলেছি 100 টাকাটা তুমি এইটার মধ্যে ডিস্ট্রিবিউট করো, you distribute over this one. So the contribution at a particular point, and all the points must get equal contribution, right? Because they are equal probable in all directions. It is a homogeneous system, right? Homogeneous isotropic, so everything is same everywhere. And now I give you the same 100 penny, আবার 100 টাকা দিয়ে বলেছি you distribute it over this particular sphere, এই স্পিয়ারটার উপরে ডিস্ট্রিবিউট করো. So the difference you understand. So now the contribution to each point will lessen. So এখন একটা পার্টিকুলার পয়েন্টের কন্ট্রিবিউশন নিশ্চয়ই কমে যাবে, তাই তো? একটা পার্টিকুলার পয়েন্টের কন্ট্রিবিউশন এখন নিশ্চয়ই কমে যাবে, বিকজ দ্য এরিয়া হ্যাজ ইনক্রিজড, রাইট? এন্ড দিস ডিক্রিজিং ফ্যাক্টর হ্যাজ বিন টেকেন কেয়ার বাই আর। এই যে ডিক্রিজ করে যাচ্ছে যে ফ্যাক্টরটা, দিস ডিক্রিজিং ফ্যাক্টর ইজ টেকেন কেয়ার বাই আর। Now you may say that, sir, why not r square or r cube? কেন r square বা r cube নয়? So there is some treatment of it which we are not doing. So সেটা তো আমরা এখানে করছি না, সেটা দেখাতে পারবো না, but I show you a bit of it, একটু আইডিয়া দেওয়ার চেষ্টা করলাম। So the things are very difficult, not so simple, এতটা সহজ নয়, but this will actually bloom up some idea within you. So তোমার মধ্যে একটা আইডিয়া ডেভেলপ করবে, so an idea will develop that will help you to think further, provided if you want to think. যদি তুমি মনে করো যে আমি আরো ভাবনা চিন্তা করব, তাহলে এটা তোমাকে সাহায্য করবে। তুমি দেখো আরো যদি দূরে যাও, if you move away, so then the same thing is now shared with a more with a larger space, and that is why the contribution to a particular point will be again decreasing. মানে আগে যদি একটা পয়েন্টে যদি 10 টাকার কন্ট্রিবিউশন ছিল, previously 100 rupees you divide over here, and a particular point gets a contribution of 10 rupees. So now over here the contribution reduces to 1 rupee, and over here the contribution reduces to 0.1 rupee, right? So it is decreasing. So as you are moving outward from the actual position of the source, the wave is decreasing. So সেটা এখানে কমে যাচ্ছে, তো সেটাই তুমি এখানে দেখছো, and that is what you also find over here. So that is being taken care by R, right? But in case of plane waves we suppose that it is coming from infinity. So as it is coming from infinity, and these are all parallel beams coming from infinity, so আমি তো জানি না যে এক্সাক্ট সোর্সটা কোথায় আছে, the source is coming from infinity. So that is why there is no question in the diminishing of the amplitude. সেই জন্য এখানে amplitude কমানোর যে ব্যাপারটা সেটা এখানেতে নেই। We take it to be some fixed amplitude because we exactly don't know the position of the source. So this type of infinite assumptions we also do in the classes of electrostatics, particularly you know কয়েকটা ট্রিটমেন্ট তো তোমাদেরকে দেখানো হয়েছে। So দেখো রিলেশন আছে, কিন্তু they are related. So the charge distribution, the infinite charge distribution. So actually the charge distributions are not always infinite. So I have said you. So most probably you have done the classes of electrostatics. If not, so then you will do later on. যদি করে থাকো, if you have done it, so you know that infinite charge sheet doesn't always mean that the sheet should be of infinite dimension. The idea is that you should be unable to see the ends of it. আইডিয়াটা হচ্ছে তুমি তার দুটো প্রান্ত দেখতে পাচ্ছ না, তুমি এন্ড পয়েন্ট গুলো দেখতে পাচ্ছ না, তাহলে সেটা কি করে করা যেতে পারে? ইউ আর ভেরি নিয়ার টু দিস ওয়ান শিট, তো তুমি এই শিটটার খুব কাছে আছো। সো ইউ সি দ্যাট ইফ ইউ আর ভেরি নিয়ার টু এ ওয়াল, তুমি যদি একটা দেওয়ালের খুব কাছে থাকো, সো দেন ইউ ক্যানট সি দ্য এন্ড পয়েন্টস অফ ইট। সো এন্ড দ্যাট ইজ ওয়াই ইট অ্যাপিয়ার্স ইনফাইনাইট টু ইউ, সেই জন্য তোমার কাছে এটা ইনফাইনাইট বলে মনে হয়। সো দ্য ইনফিনিটি, দিস ইজ আ আইডিয়া দ্যাট অ্যাকচুয়ালি অ্যাপিয়ার্স আপন দ্য জিওমেট্রি অফ দ্য সিস্টেম। সো ইনফিনিট মানে কিন্তু এমন নয় যে একটা বিশাল কিছু বড় যেটা আমি দেখতে পাচ্ছি না, so something of huge dimension or something is located at a huge distance. The idea is not always like that. Okay, so the idea, so you have to just try to understand that what actually is the system is. যেটা আমি বললাম এই যে শীটের ক্ষেত্রে, so this is the sheet and you are very near to the sheet. তুমি শীটের এতটাই কাছে আছো, you are very near to the sheet such that it appears to you as infinite. Okay, so these are the ideas that you must go through. এখানেও তাই। So the infinite, so it's the plane waves. In the plane waves the amplitudes are taken as constant. So you try to understand that from the class of higher secondary days, higher secondary থেকে তুমি জানো, you never asked this one. There was no position for you to be questioning about that because you are not too much accustomed with different wavefronts, and none of the teachers have also introduced to you about this. কেউ তোমাকে এটা বলেওনি that y is equals to, whenever you used to write y is equals to a sin omega t minus kx from your higher secondary days, so you are using the concepts of plane waves, and plane waves are basically used just for the simplicities in our treatments, right? But in actual practice it is spherical, cylindrical, this type of waves. So I hope that I have been able to give you some ideas which you find interesting, and definitely you will try to apply them in your future courses for your own betterment. So let us now come to we come to our basic ideas of the Fresnel's half period zones. So এবার আমরা একটু half period zones এইটা নিয়ে আমরা একটু আলোচনা করব. I will be discussing about the Fresnel half period zones. So now the idea is half period zones. Okay. So what are half period zones? I will be discussing about it. What is the significance of it? So actually Fresnel says that the process of light propagation for this type of finite cases of wavefront, so this actually occurs by the propagation of wavefront. তুমি জানো যে লাইটের যে propagation হয়, the light moves forward, so that is actually the propagation of the wavefronts. And what is actually going on in a particular wavefront? You know that from the Huygens-Fresnel's theory, that Huygens said that every point is a source of secondary disturbance, and then Fresnel says that all the that is when the wavefront is obstructed by something. The wavefront is obstructed by some aperture or by some obstacle. When the wavefront is obstructed, so then the phenomena of diffraction comes into the picture. So that is how. So in order to explain the diffraction, we will go through the concept of these half period zones. তো সেটার জন্য আমরা হাফ পিরিয়ড জোনস এই কনসেপ্টের উপর দিয়ে আমরা স্টার্ট করব, দ্য Fresnel's হাফ পিরিয়ড জোন. সো লেট আস কনসিডার এ ওয়েভফ্রন্ট এবিসিডি. আমরা একটা ওয়েভফ্রন্ট আগে কনসিডার করি. লেট আস কনসিডার আ ওয়েভফ্রন্ট. Let us consider a wavefront ABCD. Actually this is not the exact Fresnel's diffraction theory. এটা কিন্তু Fresnel diffraction এর exact theory নয়. So there are some complex integrals in the Fresnel's theory, so which we need to actually evaluate, যেগুলো actually evaluate করতে হয়. But as I have said that Fresnel's diffractions are easy to observe in the laboratory. You don't need too much of experimental setups, but mathematically these are difficult, and also conceptually. So conceptually এবং mathematically দুটোই কিন্তু Fresnel's diffraction এর ক্ষেত্রে বেশ জটিল. So it's quite difficult, and that is why what actually we do, we study the phenomena of diffraction to give you the idea of diffraction, that really the light enters within the geometric shadow. সত্যিকারে geometric shadow মধ্যে light enter করে, and then we also give you the idea that really there are some distribution functions, there are some distribution pattern, সেখানে একটা প্যাটার্ন থাকে, ঠিক আছে? তো সেই জন্য আমরা phenomena of diffractionটা আগে স্টাডি করাই. So we study the phenomena of diffraction, get some ideas, get some knowledge, and then we slowly move on to the Fresnel's diffraction. এবং তারপরে আমরা Fresnel diffraction slowly and steadily we go to the Fresnel diffraction. But Fresnel diffraction, you believe me that this is only a alternative way to study Fresnel's diffraction. So definitely the ways have been devised by Fresnel, but actual the Fresnel-Kirchhoff theory বলে একটা আবার আছে, Fresnel-Kirchhoff. So there you have to go through some difficult integrals and something which are very difficult for you to understand. So presently not we don't put stress too much on this particular course, so এটাতে আমরা খুব একটা জোর দিই না. So because we expect that you will get the questions at the time of exams, you will get the questions from these discussions only, mainly from phenomena diffractions and a few questions from Fresnel diffraction, and whatever will be discussed, I hope that will develop a proper physics understanding within you. তোমাদের মধ্যে একটা physics understanding ও develop করবে, and in addition to that the examination purpose will also be served. So we considered a wavefront ABCD over here. So we considered a wavefront ABCD over here. Not necessarily it is a plain wavefront, so just a wavefront, you may take anything. Let us consider a wavefront ABCD corresponding to wavelength lambda. Corresponding to wavelength lambda. So what is our goal is that we want to find the effect of the wavefront. We want to find the effect of the wavefront. We want to find the effect of the wavefront. We want to find the effect of the wavefront. We want to find the effect of the wavefront at a distant point capital P. At a distant point capital P. We want to find the effect of the wavefront at a distant point capital P, right? At a distant point capital P. এটা আমরা বের করতে চাই। That is, we want to find the intensity, and you will find some remarkably beautiful result over here. এত সুন্দর রেজাল্ট তুমি পাবে, and you will understand that why actually light enters within the geometrical shadow, and you will also understand that why to observe diffraction you need the size of the obstacle to be of that of the wavelength. So ছোট সাইজের obstacle কেন লাগে? Why do you need obstacle of smaller sizes? That will be also understandable from this, right? So the class is going to be very interesting. You will get some beautiful ideas towards the end of the class. শুরুর দিকটা একটু ম্যাথমেটিক্স আছে, at the very beginning we have some mathematics, but once you overcome those ideas, we will encounter beautiful ideas towards the end of the class. So be with us for 1 hour. I hope that within 1 hour or 1 hour 15 minutes, we will develop some beautiful concepts in this particular class. So let's enjoy. Let me draw some diagram. These zones are called half period zones. এইগুলোকে আমরা half period zone বলে থাকি। Okay, these are called the half period zones. I cannot draw them perfectly, nor I am trying to do it perfectly. না তো পারফেক্টলি করতে পারবো, না চেষ্টা করছি। These are circles. You have the transverse view of it, sideward view, হ্যাঁ, সাইড থেকে দেখছি, as if I am looking at it from a particular side. এগুলোকে জয়েন করতে হবে। দেখো অবস্থা, see what happens. It's very difficult to do without scale and pencil. It's really difficult to do. চলো চেষ্টা করেছি, I have tried my level best. Please adjust, okay? এই বুঝে নিও, এখানেতে অ্যাডজাস্টমেন্ট বুঝে নিও, try to understand the adjustment, because I cannot do better than this. এর থেকে আর ভালো কিছু করতে পারছি না। চলো যথেষ্ট হয়েছে, ফাইন, not at all bad. What is going on? Yeah, fine. This is my point capital P. This is my wavefront. So I want to find the effect of this wavefront at the point capital P, right? So right now we are not having any diffraction or anything like that. So এই মুহূর্তে আমার কাছে কোনো diffraction বা কোনো কিছু নেই. We just want to find the effect of this on these particular points. So I have some M1, M2 over here. So এখানে আমার কিছু M1, M2 points আছে. So actually I mark them like this. So this particular point, এই particular point টাকে আমি M1 বলছি. This point I call M1. This point I call M2. Suppose this one I called M3. And similarly, this is my nth zone. Suppose this one I call Mn. Okay. Now this distance I call, this distance is my, suppose some P, small p. This distance is small p, that is from the wavefront to the point P. So wavefront থেকে point P, the center of the, that is from the wavefront to the point P. So this distance is some small p. The next distance I call it P plus lambda by 2. You understand that the distance are slowly increasing. তুমি এটা বোঝো যে distance গুলো বাড়ছে আস্তে আস্তে. The next one is P into twice lambda by 2. and then I go for the last one, which is p plus n lambda by 2. Okay, there are other points in between, and finally it is the n lambda by 2. So that is the idea that we have done. So কি করলাম একটু লিখে দিই. So let me write whatever I have done over here. So from capital P we drop a perpendicular. From capital P we drop a perpendicular OP on the wavefront. We drop a perpendicular OP on the wavefront of length P. So P length একটা এখানে drop করব. Fine. Next point is, now with capital P as center, these are all suggestions of Fresnel. We are bound to follow him. আমরা ওনাকে follow করছি. Now with capital P as center, we draw spheres. We draw spheres of radii. We draw spheres of radii. আমরা sphere draw করা শুরু করব. We draw spheres of radii. Of how much radii? We draw spheres of radii p plus lambda by 2, p plus twice lambda by 2, comma dot 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 up to p plus n lambda by 2, such that I can cover the entire wavefront. পুরো wavefrontটা কভার করতে হবে, সেইভাবে ড্র করছি. We draw spheres of radii center at p and radii at of this much lengths. এরকম করে আমরা স্পিয়ার ড্র করলাম. Now with p as center, we draw spheres of radii this one. The sections of the sphere by the wavefront. The sections of the sphere by the wavefront. Section. The sections of the sphere by the wavefront. The wavefront is a plane, you understand. It's a plane. The section of the wave spheres by the wavefront are circles. Not only circles but concentric. I forgot. Homocentric. All are having the centers at the same point. By the wavefront are concentric circles with the center at capital O and radii. And what is the radii of these spheres? And the radii of these spheres are OM1, and the radius of the spheres are OM1, OM2, comma dot dot up to OMM. Okay, so আমরা draw করলাম spheres, and you know that if I give a section to the sphere, so then you will get circles like this. So আমরা এখান থেকে circles পাবো. So if I give, so then I will get circles from here. If I give আচ্ছা এখানে ওয়েভফ্রন্টটাকে নাম দিয়ে দিতে হবে. ABCD is the wavefront. So this wavefront gives some sections. This wavefront gives some sections to the spheres. মানে you take a potato, তুমি একটা আলু নাও, and then you cut that potato. আলুটাকে কেটে দাও, মানে সেকশন দাও একটা. With a knife you give a section to that potato. So whatever you have a potato chips. তোমার কাছে একটা potato chips পাবে, and that is, you understand, that is circular. Chips এর সাইজ তো স্পিয়ার নয়. Your potato, আলু, ওটা স্পিয়ার ছিল. আলু was sphere. But the potato chips that you are eating, তুমি যে চিপসটা খাচ্ছো, that is circular, that is not spherical. And what happened to it? You have given a section to it, and here the section is given by the wavefront ABCD. So ABCD সেই সেকশনটা দিয়েছে. So taking P at center and this as the radius, we draw spheres. আমরা এখন করে স্পিয়ার ড্র করেছি. And when a section is given to this particular sphere, যখন আমরা সেকশন দিচ্ছি এখান থেকে, so once a section is given, you get circles, and that circles are drawn over here on this particular wavefront. And the radii of the circle you understand from this diagram. So এই particular point টা হচ্ছে O. This particular point, it's very difficult to draw over here. I hope that you people will draw it better. আমি আশা করি তোমরা নিশ্চয়ই ভালো করে ড্র করবে. আমার তো এছাড়া উপায় নেই. I suggest you to draw right M1 over here. এখানে M1 লিখবে, এখানে M2 লিখবে, and so on you do it. Okay, so then it will appear good and it will look better. ভালো লাগবে দেখতে. Follow your book for the diagram. বই দেখে নেবে, বইয়ের মধ্যে ভালো করে আছে. তাহলে এই হচ্ছে তোমার টোটাল স্টোরিটা. তাহলে তুমি এখানে দেখতে পাচ্ছ, so you find that you get some zones over here. My diagram is not at all good. Please try to draw a good diagram. You see that you have some zones over here. Okay, এখানে একটা জোন তৈরি হয়েছে. This is a zone. then you see that this one is a zone. Protect all the zones. So there are some zones which are produced over here, and these zones are called the half period zones. Half period. So why half period? Because the separation from the separating distance, you see, that is from the point P to M1. So P to M1, this one distance is lambda by 2 plus P, and then if you go for P to M2, then it is twice lambda by 2, it is twice lambda by 2 plus T. So if you subtract these two, you get lambda by 2. এই দুটোকে subtract করলে তুমি lambda by 2 পাবে, you get lambda by 2 over here. So as we know that wavelength lambda corresponds to a complete wavelength, a complete period. Wavelength lambda মানে কি একটা complete period তো. So this wavelength is lambda. This means a complete period, a complete time period. So, but if you have a lambda by 2, so then it is only half cycle, it is only the half. So that is why these zones are called half period zones, because of this lambda by 2. So as the separation from one zone to another zone is given by this lambda by 2 with respect to the point P. Point P এর রেসপেক্টে একটা জোন থেকে আরেকটা জোনের সেপারেশন lambda by 2, the separation is lambda by 2. So that is why these are called half period, because lambda corresponds to full period and this corresponds to half a period. So things are well understood by you. So বুঝে গেছো কি বলতে চাইলাম, ফাইন. So let us write it. So সেটা একটু লিখে দিচ্ছি এখানটাতে আমি. The area within the first innermost circle, the area within the first innermost circle, the area within the first innermost circle is called the first half period zone, is called the first half period, is called the first half period zone, is called the first half period zone. তারপরে the annular region, the annular region between the first and second circle, between the first and the annular region between the first and the second circle is called, in the first and the second circle is called the second half period, is called the second half period, is called the second half period zone. Got the idea? So the area within the first innermost circle is called the first half period zone. The annular region between the first and second circle is called the second half period zone. Okay, so first half period zone and then you have the second half period zone. তাহলে একদম innermost যেটা, the innermost is the first half period zone and the next one is the second half period zone. So that means that this one, so this one is your basically the first half period zone. এটা first half period zone, কিন্তু এই পরেরটা, this one is your second half period zone. Okay, and so on the things will move on. So এইভাবে পুরো প্রসেসটা চলতে থাকবে. So this is how the entire process will move on. So things are well understood. বুঝতে পেরেছো নিশ্চয়ই কোথায় কি বলতে চাইলাম, ঠিক আছে? And why half period? So that is also I have discussed with you, because the separation from one zone to another zone is lambda by 2, which is half a period, because lambda corresponds to a full period. So let us now try to find out the radius and the area, the average distance, everything for these particular zones. The first heading that I will put over here is the area of the nth zone. Area of the nth zone. What is the area of the nth zone? So that is what I will calculate next. So the area enclosed between nth and n-1th circle is called the nth half period zone. So let me write it. The area enclosed, so nth half period zone কাকে বলবো? The area enclosed between, the area enclosed between the nth, the area enclosed between the nth and n-1th, nth and n-1th circle is called the nth half period zone, is called the nth half period zone. হ্যাঁ, এটা আমি বারবার লিখতে হবে, HFZ I write today because I have to write it a number of times. Because you see that what is your second half period zone? Second half period zone কোনটা? So this magenta shade, this one is the second half period zone, and it is included between which two? It is included between the first one, that is n equals to 1 and n equals to 2. It is included between this n equals to 1 and this n equals to 2. N equals to 1 আর 2 এর মধ্যে আছে. That is the second half period zone is included between which two n's? The second half period zone, the second half period zone is included between which two? The second half period zone is included between the second and the first. 2 minus 1, right? 1 is 2, একটা 2 আছে আর একটা n এর ভ্যালু কত আছে? 1 আছে. So that is why, so nth and n minus 1th, এইভাবে ভাববে. This way you think. The third half period zone I will show you next. পরেরটা দেখাচ্ছি third half period জোনটা. This is your third half period zone. এটা third half period জোনটা, হ্যাঁ, this is the third half period zone. So that is present between n equals to 2 and n equals to 3. n equals to 2 and n equals to 3. So third one, the third one will be definitely present and the lower one, that is n equals to 2. So that is what I have done over here. So সেটা এখানটাতে লিখলাম. So that's my definition. So and whose area will be given by what? So how will you get the area of that one? So for that, let me find the radius of the nth zone, radius of the nth circle বের করি, radius of the nth circle. This will be utilized somewhere. এটা কোথাও না কোথাও কাজে লেগে যাবে আমাদের. So let us find the radius of the nth circle. So what is the radius of the nth circle? So obviously it will be given by OMN square. Nth circle OMN square দিয়ে পাবে, radius of the nth circle is OMN square. And what is this OMN square? So OMN square, if you go for the Pythagoras theorem over here, OMN square, that is some PMN square minus OP square. PMN square minus OP square. I have to write a root over here. PMN square minus OP square. The radius is not square. The radius is simply OMN. তাহলে বুঝতেই পারছো Pythagoras theorem OMN square মানে হচ্ছে PMN square minus PO square বা OP square. So this actually gives me. So এটা কত দেবে আমাকে? So what will be the value of this? So this actually gives me P plus n lambda by 2. P plus n lambda by 2, that one whole square, minus P square. So that actually reduces to some n square lambda square by 4 plus n lambda square root. That is what you have. N square lambda square by 4 and 2p into n lambda by 2. 2 and 2 gets cancelled. So n lambda into p. N lambda into p. Right? Now lambda is basically the wavelength in the visible spectrum. So this n square lambda square term you may reject it. So you may just write it n lambda rho. So rho cannot. So n lambda p. So you may write it to be nearly equals to n lambda p. So it nearly we can write it to be n lambda p like this. Okay. So that is the value. You can nearly write it to be n lambda p. The exact value is this one. Exact value এটা আসে. So I should box up this one first. So এটাকে আগে box করা উচিত because এটা আমার exact value টা. This is my exact value for the radius of the nth circle and this is my approximate value. আর এটা হচ্ছে approximate value since lambda is very small. Right? তাহলে what is the area enclosed between nth and n minus is called the nth half period zone. So what is the area of the nth half period zone? So the area of nth half period zone, area of nth half period zone, if I call it AN, so that should be pi. You know that it is nth minus n minus 1th. Nth আর n minus 1th এর মধ্যকারটা, the area between nth and n minus 1th. So OMN square minus OM n minus 1 square. That is what I have. So now OMN I have over here already. OMN already আমাদের কাছে আছে. So that one will give me n square lambda square by 4 plus n lambda p minus, and then you have to replace n with n minus 1. So that gives me n minus 1 whole square lambda square by 4 and minus n minus 1 lambda into p. So that is the value which I have at this moment. So এই হচ্ছে ভ্যালুটা. So এখান থেকে আমি pi পেলাম, I get the value of pi, and you see that after different types of cancellations, what I have, these two terms will get cancelled. N square lambda square by 4 will get cancelled from here, and this one minus n lambda p and this n lambda p will get cancelled. So এই term দুটো কিন্তু already cancelled হয়ে যাবে. These terms will get cancelled over here with what? So let me mark it. So this one gets cancelled with this n and this one gets cancelled with this n. So whatever I have over here is that, তাহলে যেটুকু পড়ে থাকে সেটা হচ্ছে আমাদের এখান থেকে from here I have a lambda square by 4 and then I have positive of minus minus plus 2 times of n lambda by 2, so that is n lambda by 2, তাই তো? n lambda by 2, n lambda by 2 আসবে, and from there you have a term which is positive of lambda p. The term is positive of lambda p. So this will give you some lambda p, right? So this will give you some lambda p. ঠিক আছে? So this gives you some lambda p. একটু যদি গুছিয়ে লেখার চেষ্টা করি, if I try to arrange it properly, then I hope that it can be written as twice n minus 1 into lambda square by 4, twice n minus 1 lambda square by 4 plus lambda of p. দেখে নাও অ্যারেঞ্জ করে। সো n lambda square by yes, plus হবে, yes, it will be plus lambda square by 4 I have, this will be also lambda square, you see এটা তো lambda square ই হবে, তাই না? 2n, because there is a lambda square already, so that will be lambda square. So hopefully it is understandable. So lambda square, let me check it, n lambda square by 2 at a lambda square by 4. Fine, it's perfect. So that is the area of the nth zone. So this is the area of the nth zone, and if you just reject the lambda square term over here, so lambda square term যদি আমরা reject করি due to the smallness in lambda, so we may write it to be this an goes to some pi lambda p. কখন? if lambda is very small, neglecting, বা তুমি লিখতে পারো neglecting lambda square due to smallness, neglecting lambda square. So lambda square যদি neglect করে দাও, so then you will have pi lambda p. So that is pi lambda p. Okay, so when you neglect that lambda, and from here you can say that the area of the zone are nearly independent, the area of the zone are nearly independent of the order. So মোটামুটি দেখো এরিয়াটা কিন্তু independent of the order. Strictly speaking, the area slightly increases with order. So তুমি যত higher order এ যাবে, as you go for the higher orders, the area is increasing, right? If you put n equals to 1, you will get over here what? 3. But if you use n equals to 2, you are going to get 5. If you use n equals to 3, you get 7 over here. So that's the area is increasing, right? But the increase in area is very slow. Area টা এখানে increase করছে ঠিকই, the area is definitely increasing, but the increase is very slow because of this lambda square. So if I assume this lambda square to be neglected, then you see that you get pi lambda p, which is nearly constant. So let me make that conclusion. So thus, because this is a question at the time of exam, that show that the area of the half period zones is nearly independent of the order, right? Thus the area of a half period zone is nearly independent. Area of a half period zone is nearly independent of the order, of the zone, right? Is nearly independent of the order of the zone. However, for exact calculations, the area slightly increases. The area slightly increases with order. So যত তুমি higher zones এ যাবে, as you will go towards the higher zones, so you will have the more and more area. Okay, so let us now find the average distance. So here I will be finding out the average distance of the nth zone from P. Average distance of the nth zone from P. Average distance of the nth zone from P. So that one will be, so again you know that nth zone means it is the nth and n minus 1th zone. So distance circle. What is the distance of the nth circle? So the distance of the nth circle is P plus n lambda by 2. And what is the distance of the n minus 1th circle? That is n minus 1 into lambda by 2. Got the idea? And this one is divided by 2. you know that the nth zone is produced by two consecutive circles. এই দুটো সার্কেল নিয়ে তৈরি হয়। So this distance you know and this distance you know, right? এই দুটো distance তুমি জানো, you know this distance, you know this. So take the average, so that is the average distance of the nth. So এটা হচ্ছে average distance, okay? So it is the average distance that you take over here. So that gives you actually, so এখান থেকে তুমি যেটা পাবে, so from here you will get some twice p plus twice n minus 1 into lambda by 2. Lambda by 2, yeah, and then divided by 2. So that actually gives us, so সেখান থেকে আমরা পেয়ে যাই p plus twice n minus 1 lambda by 4. So that is your dn. And once again you see that if you neglect that lambda, so then you will get something from here. You will get something simplified from here. So এটা তোমার dn এর ভ্যালুটা আসছে, but you see that you can write it to be nearly equals to p. So nearly আমরা এটাকে p নিতে পারি, provided since you know that this lambda is very less than p. So p এর থেকে ল্যামডাটা খুবই ছোট হবে। ল্যামডার অর্ডার কি আছে? ল্যামডা is of the order of angstrom and p is of the order of some meter or centimeter. সেন্টিমিটারও নয়, p মিটারেই থাকে। p is of the order of meter, p is of the order of meter, okay? And lambda is of the order of 10 to the power minus 10 meter, ঠিক? p টা হচ্ছে 1 মিটার and lambda is 10 to the power minus 10 meter. So that is you can easily reject it. তুমি খুব সহজেই এটাকে রিজেক্ট করতে পারো। You can reject it very simply, okay? So that is dn is p. So once again you may draw the same conclusion that the average distance is independent of what? Independent of the order, right? But strictly speaking it increases. Increase to korche, it is definitely increasing because first one is p, then p plus lambda by 2, then 2 lambda by 2, then 3 lambda by 2. So obviously it is increasing, but the increase is very slow such that we take it to be a constant for our calculation simplicities. Because you will see that within 15 to 20 minutes or at best half an hour you will see that these issues are not at all a issue. So এই ঘটনাগুলো কোনো ঘটনাই নয়. So these are not the issues. The issue is somewhere else, something else which you will understand, right? And the main issue is the obliquity factor which you will understand over here. So main issueটা হচ্ছে obliquity factor যেটা তোমরা এখানেতে বুঝবে এই জায়গাটাতে। তো সেটা আমরা এখানটাতে দেখানোর চেষ্টা করছি। The next I will try to show you over here. So the next one is that Fresnel's assumptions, amplitude or disturbance at p due to a zone. So আমরা লিখছি, so I write it, amplitude I call it disturbance or I may call it intensity later on. Amplitude or disturbance at p due to a zone. Disturbance at capital P due to a zone. Disturbance at capital P due to a zone, right? Fresnel's assumption. Fresnel's assumption. And you will see that this will give you some correct features. এবং এখান থেকে কিছু সত্যিকারের ফিচার আমি পাবো, and that is why the Fresnel's assumptions has been universally accepted. সেই জন্য Fresnel যা বলেছিল মানুষ অ্যাকসেপ্ট করেছিল, people have accepted it. So what are his assumptions? His assumptions are the amplitude of disturbance at capital P due to a zone, at capital P due to a zone is independent, is dependent on the following factors, okay? The amplitude of disturbance at capital P due to a zone is dependent on the following factors. So what are those factors? So let us try to analyze one after another. আমরা দেখি একটা একটা করে কি সেই ফ্যাক্টর। Number 1, directly proportional to what? Directly proportional to the area, directly proportional to the area of the zone, directly proportional to the area of the zone. Number 2 is inversely proportional to the distance of the zone, distance of the zone, okay, inversely proportional to the distance of the zone. Distance এর সাথে inverse proportion আছে, that is what we have started the class with. ক্লাসটা সেটা দিয়ে শুরু করেছিলাম, inverse proportional with the distance. So that is the next idea. And the finally it is directly proportional, it is directly proportional to the obliquity factor, to the obliquity factor. So obliquity factor মানে this obliquity factor, actually to the obliquity factor I will show you in details, directly proportional to this an, inversely proportional to dn, and directly proportional to the obliquity factor theta n, যেখানেতে where theta n is the angle shown in the figure, where theta n is the angle, theta n is the angle as in figure, where f theta n is equals to maximum, f theta n is maximum at theta n equals to 0 degree and minimum at theta n equals to 90 degree. So এটা হচ্ছে আইডিয়াটা. So this is the idea. So there is a dependence of some obliquity factor. This has been said by Fresnel. So এটা Fresnel বলেছিল, আমি তোমাকে ডিটেইলস দেখাচ্ছি. Let me go back to the diagram. So this angle is theta n. এই যে অ্যাঙ্গেলটা তৈরি হলো, this angle over here is called theta n. So the first zone makes the angle that is theta 1, second zone makes the angle theta 2 with this OP. OP এর সাথে কিন্তু অ্যাঙ্গেলটা, হ্যাঁ, the angle is with OP. Let me show you in this way for your better understanding. This angle is theta, right? So the angle which is made by OP and the nth circle, that is theta n. Angle made with OP with the first circle, that is theta 1. এবং আমরা বলছি যে এই এফেক্টটা, এই যে f theta, এই টার্মটা ম্যাক্সিমাম হবে when the angle is 0. That is for direct incidence. বোঝো এখানেতে পরিষ্কার, theta 0 কখন আসবে? When the light comes from this one, that is the direct incidence. So during direct incidence, this obliquity factor value is maximum, and for all other incidences there will be some lesser effect. যত দূর থেকে লাইটটা আসবে, so as the theta n is more and more, the effect will be lesser. So this has been what said by Fresnel. So এটা Fresnel বলেছিল. So Fresnel এরকম বলছে, so ধরো এটা হচ্ছে সোর্সটা, এটা স্ফেরিক্যাল ওয়েভফ্রন্ট, so the light is moving like this, এরকম ভাবে লাইটটা জ্বলছে. So as said by Huygens, so Huygens এটাই বলেছিল. This was the Huygens concept. Huygens কিন্তু এটাই বলে that the light propagates in the forward direction. এখান থেকে যে লাইটটা যাচ্ছে, this one, so this propagates in this particular direction. Okay, there is no sideward propagation. Sideward propagation এর কথা কিন্তু Huygens বলে না. Huygens don't say it. Now Fresnel come into the picture and Fresnel says, no, this is the source of secondary disturbance. So this secondary disturbance can send light in any direction, not only in the forward direction, it can send light in this direction also. এটা এই দিকেও লাইট সেন্ড করতে পারে, it can send light in this direction also. So then this is some angle alpha. So এটা হচ্ছে একটা angle alpha আসবে এখানে. So then there will be some angle alpha, and the propagation in this direction will be proportional to, so our alpha আর proportional একই রকম হয়ে যাচ্ছে. So this one is, so let me change this angle, let me call it beta. So this side the propagation is proportional to 1 plus cos beta. So এই দিকের proportionality হচ্ছে 1 plus cos beta. This has been shown by some details calculation which is not possible in this undergraduate course, যেটা এই কোর্সে দেখানো সম্ভব না. And even in any textbook of undergraduate course you will find it. তুমি কোনো বই এটা পাবে না. You have to go through some research journals, so where this has been done, right? So this has been said by Fresnel. So now the light can come in this direction also. এই দিকেও লাইট আসতে পারে, the light can come this direction also. So it is proportional to, so if I call this angle to be beta 1, this angle, suppose the previous one was beta and this one you suppose beta dash, so this time the intensity will be proportional to 1 plus cosine of beta dash. It will be proportional to 1 plus cosine of beta dash. And this is the reason that backward propagation is not possible. আমরা তো ভাবতেই পারি না, this is the source of secondary disturbance, so why only forward? Light can go in the backward also, but you see that for backward direction this angle should be actually how much? So for forward direction the angle is how much? Forward এ গেলে the angle is 0 degree, then the angle slowly increases, and if it is pi, মানে 180 degree, if it is pi, so you see that your cos pi is minus 1, and then this will actually become 0. So cos pi is -1, and this is the reason that backward propagation is not possible in case of the waves. Okay, and you also remember that this has been said by whom? By Fresnel. এটা হাইগেন্সের থিওরিতে কিন্তু ছিল না। Huygens theory was only the point. This one is a point of secondary disturbances, the light will proceed forward. This one is the point of secondary disturbances, light will proceed forward, and then you join the points of same phase and you get the next wavefront. So that was Huygens, but Fresnel says no, light can go in these directions also. এরকম arbitrary directionেও কিন্তু লাইটের মুভমেন্ট হতে পারে, right? And that disturbances actually decreases as the angle is increasing. এবং যত অ্যাঙ্গেলটা ইনক্রিজ করছে from the forward direction, as the angle is increasing and increasing, as the angle, that is betas, are increasing and increasing, the effect will be lesser and lesser. So effectটা কিন্তু তত সেখানে কম পড়বে, the effect will be lesser and lesser, and that is why you see that this one, if I call the forward direction, so then this one is some at angle, so এটা কিন্তু একটা অ্যাঙ্গেলে আছে. If this one I call forward direction, so then this one is at an angle, right? So these effects will be lessen up due to the obliquity factor as said by Fresnel. তাহলে Fresnel যেভাবে obliquityর কথা বলেছে, তো obliquity থেকে এটা আসবে. Obliquity কিন্তু details deduction আছে. Obliquity is not an assumption, but this is a details deduction is there, which we are not trying to do in this class. খালি আমরা কি করে বলে দিচ্ছি, we call the obliquity factor to be f theta n. I don't put all those cos thetas and everything. ওই cos theta ইত্যাদি ওইসব আমরা পুট করিনি. সো আমরা এখানে বলছি এর ভ্যালুটা ম্যাক্সিমাম আসবে when থিটাটা 0 হবে. When the theta value is 0, you get the maximum value, and when the theta value is 90 degree, you get the minimum. Don't get confused with this theta with that beta. ওখানে যে বিটা অ্যাঙ্গেলটা দেখিয়েছিলাম আর থিটা অ্যাঙ্গেল কনফিউজ হবে না কিন্তু, হ্যাঁ, this is the different things. That is the angle made with the wave front normal. ওটা ওয়েভ ফ্রন্টের নরমালের সাথে যে অ্যাঙ্গেল করেছিল, ঠিক আছে, এখানে একটু অন্যরকম ব্যাপার আছে. So here the things are different but related. Those angle and this angle is related, so definitely তারা related আছে, but you understand that they are not exactly the same. So don't try to match up with those. হ্যাঁ, so সেই জন্য তুমি ম্যাচ আপ করার চেষ্টা করো না. মানে এখানে আমরা বলতে চাইছি যত দূরের জোন থেকে আসবে, as you are getting the contribution from the further zones, so the obliquity factor will be increasing, theta n টা বাড়ছে, and you know that as theta n is increasing, the f theta n is decreasing. That is very much clear from here. F theta n is maximum at 0, and then you see f theta n is decreasing. F theta n কিন্তু পরবর্তীতে কমে যাচ্ছে. As you are going towards 90 degree, your f theta n is going towards 0 or minimum values. 0 বলছি না, we are saying that f theta n is minimizing. Okay, so that will be a minimum effect, you will get it over there. So I hope that the things are understandable. তোমরা আশা করি বুঝতে পেরেছো. So প্রত্যেকটা ফ্যাক্টর যদি আমি একসাথে টেক কেয়ার করি, so taking care of all the factors, taking care of all the factors, taking care of all the factors, the amplitude of the nth zone, taking care of all the factors, the amplitude of the nth zone is proportional to. So you may write it that an is proportional to what? It is proportional to capital An into 1 by dn and into f of theta n. Although f of theta n appears to be direct proportional, but as theta n is increasing with the order number এর সাথে f theta টা বাড়ে, with the order number this f theta is increasing, and as the f theta is increasing, as theta is increasing, your f theta is decreasing. মানে basically কিন্তু amplitude কমবে. So here you will see a very important relation over here. This an is proportional to what? An কার সাথে proportional দেখো, I take the simplified version, that is n lambda p. তো না ওইটা নয় রে, কোথায় গেল? ওহো, আমি মাঝখানে পেজ দিয়ে দিয়েছি ভুল করে. I have entered a page in between by mistake. Let me remove it. এটাকে আমরা রিমুভ করে দিচ্ছি. এই লেখাগুলো লিখে নাও. You please write all this, or you may write it later on. So I am just moving out this page. Just I move out this page, some dot, whatever you have already written. So an is proportional to, what is the value of, it is proportional to 1 by a dn and f theta n. আচ্ছা, এবার দেখো এখানে দেখো ভালো করে, an টা কি ছিল? an was proportional to what? Capital An. dn is proportional to p, dn is p, and this one is pi lambda p. ওইটাই লেখো. সিম্পলিফাইড ভার্সনস গুলো লেখো। এটা পাই পি ল্যামডা, এটা হচ্ছে পি, এন্ড এটা হচ্ছে এফ থিটা এন। এফ থিটা এনটা কিছু করতে হবে না, জাস্ট মনে রাখবে এন যত বাড়বে, অ্যাজ এন ইজ ইনক্রিজিং, এফ থিটা এন ইজ ডিক্রিজিং, পি গেটস ক্যান্সেলড, সো ফাইনালি ইউ হ্যাভ দ্যাট এ এন ইজ প্রপোর্শনাল টু এফ থিটা এন। ওকে, এই জন্যই বলেছিলাম, দ্যাট ইজ ওয়াই আই হ্যাভ সেড টু ইউ দ্যাট অ্যাভারেজ ডিস্টেন্স এরিয়া দিস আর নট গোয়িং টু প্লে এনি রোল, দিস ইয়ার নট অ্যাট অল এনি ইস্যু, এগুলো কোনো ঘটনাই নয়। দেখো এএন ডিএন জাস্ট বললাম, I have said it, but these effects get cancelled. So finally the effect that you have over here is only that of the f theta. So যে রোলটা ফাইনালি প্লে করবে, the final role is played by the obliquity factor only. So obliquity factor plays the final role over here. And from here you understand that as you are moving towards the outer zones, তুমি যত বাইরের জোনের দিকে যাচ্ছ, as you are moving towards the outer zones, the effect is diminishing in nature. So effectটা কিন্তু তত কমে যাচ্ছে. These are the Fresnel assumption. Now why people will believe Fresnel? Because Fresnel's discussion finally gives you the correct predictions. The experimental observations are well matched. Experimental observation গুলো ঠিকঠাক ভাবে ম্যাচ করে গিয়েছিল। সো চলো এবার আমরা সেটাই ডিসকাস করি। সো from this discussion of near about 1 hour, so 1 ঘন্টার ডিসকাশনে এটাই আমরা শিখলাম। We learned, let us recapitulate our last 1 hour's discussion, just keeping the required points. Our wavefront is divided into number of zones, and the amplitude at the point capital P from a particular zone is proportional to the obliquity factor only, which has a nature of decreasing type. So amplitude টা শুধুমাত্র obliquityর উপর ডিপেন্ড করে, the amplitude depends only upon the obliquity factor, and that obliquity factor has a diminishing nature, এবং তার একটা diminishing nature আছে। তাহলে এবার সমস্তগুলোর এফেক্ট একসাথে নিই, let us consider the effect of all the zones together and find its effect at capital P, right? So I hope that you are enjoying now. So নিশ্চয়ই ভালো লাগছে, so আরো ভালো লাগানোর চেষ্টা করি। Thus the amplitude of disturbance at capital P due to a particular thus the amplitude of disturbance at capital P due to a particular zone decreases as we consider the outer zones, ঠিক আছে, পরিষ্কার। the resultant amplitude due to the entire wavefront will be a contribution from all the half period zones, will be a contribution from all the half period zones, right? All the half period zones মানে কি? That is interference, তাই তো? Interference, Fresnel বলেছে interference of the secondary disturbances, that is interference of the waves, interference of the secondary waves from all the zones, but from the different zones, interference of the secondary waves from the different zones. However, the path difference from one zone to another is lambda by 2. কিন্তু একটা জোন থেকে আরেকটা জোনের পাথ ডিফারেন্স কত? What is the path difference? And that will affect the phase part of it. So এটা phase part এ এফেক্ট করবে amplitude. The first one amplitude is A1, the second is A2, third is A3, তাই তো? A1 plus A2 plus A3, কিন্তু A1 plus A2 plus A3 তো লেখা যাবে এরকম ভাবে, ফেজ পার্ট গুলো তো আছে। So A1 e to the power omega t minus k1, A2 e to the power omega t minus kr, something like that. So এইভাবে লিখতে হবে। So ফেজ গুলো কত আছে? So what are the phases? So সেজন্যই লিখছি, however the path difference from one zone to another, however the path difference from one zone to another is lambda by 2, and hence there is a phase difference of phi, and hence there is a phase difference of how much? Phase difference of pi between the waves coming from consecutive, coming from consecutive, there is a phase difference between the waves coming from consecutive zones. So একটা zone থেকে আরেকটা zone there is a phase difference from the zones. তাহলে what will be the total amplitude? So therefore the total amplitude at capital P total amplitude at capital P A1, you see that the next one will be minus. Why? Because they are in opposite phase. Opposite phase আছে সেজন্য একটা minus part আসবে. So it will be not added up, but it will be subtracted because they are in opposite phase, exactly opposite phase. So A1 minus A2 plus A3, and this will move on minus A4, right? এইভাবে কিন্তু চলতে থাকবে plus A5 minus dot 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 dot. So it will be minus 1 to the power n. তাই তো minus 1 to the power of n minus 1 হবে minus 1 to the power of n minus 1 into an, because you see that if I put n equals to 2, so then there will be a minus sign. If I put n equals to 3, so this will be squared and that will be plus, তাই তো? So to the power of n minus 1, to the power of n minus 1. তুমি বলতে পারো স্যার n plus 1 নয় কেন? Why not n plus 1? আরে n plus 1 exist করে, কতগুলো জোন আছে? How many zones are there? The last zone is the end. So কেন তুমি n plus 1 লিখবে? Why will you write n plus 1? n plus 1 তো exist করে না, n plus 1 doesn't exist. The last existing point is n. So that is why I have written n minus 1. Mathematically you can write n plus 1, but you remember physics is not about mathematics. So this is about the significances, about the ideas that you develop. So সেই জন্য n minus 1 ই লিখতে হয়. You have to write n minus 1. If you write n plus 1, mathematically it's correct, but not physically. Okay, because n plus 1 এর zone is not formed at all. সেটা তো তৈরি হয়নি, কেন লিখবো? Why will I write it? So now I write it in this way: A1 by 2 plus of A1 by 2 minus of A2 plus of A3 by 2 plus of A3 by 2 minus of A4 plus A5 by 2 plus A5 by 2 plus dot dot dot. So whatever I have done is that the odd zones I have written is add half plus half, and the even one I left it as it is. Or you may think that those which are associated with negative sign I kept as it is. যেগুলো নেগেটিভ সাইন ওয়ালা সেগুলোকে যেমন ছিল তেমন লিখেছি. The negative I kept as it is, and the positive terms I have taken as half plus half. So that is what I have done. Now whatever you can do over here, so we will try to go for approximation. এখানটাতে না আমরা একটা approximation করব. We will go for an approximation over here. So the approximation is like this. So now you see that very obvious is that A1 is greater than A2 and A1 is greater than A2 and A3 is less than A2. That's very obvious, তাই না? That is very obvious over here. A1 is greater than A2 and A3 is less than A2. মানে as you are going towards the higher zones, it is what? Decreasing in nature. So A1 A2 এর মধ্যে যদি compare করি, if you compare between A1 and A2, so obviously who is greater? So obviously who is greater? Obviously A1 is greater. And if you compare between A2 and A3, who is greater? A2 and A3 এর মধ্যে বড় কি হবে? Definitely A2 will be greater because of this obliquity factor. You have learned it. So as theta n is increasing, মানে outer zones, as theta n is increasing, as theta is going higher, your f is going below, and that is why a is also going down. So as you are going toward higher zone, n is increasing, theta is increasing, but the obliquity is decreasing, and hence the amplitude is also decreasing. So hence you are going toward the outer zone, so you may safely write that A1 is greater than A2. Better eta lekha, it's better to write in this way: A1 is greater than A2 and A2 is greater than A3. So that means you can write that A2 is somehow between A1 and A3. তাহলে A2 টা মোটামুটি A1 এবং A3 এর মাঝখানে আছে। লেখাটা ঠিক হলো না, কিন্তু A2 টা এটা লিখতে পারবো না, সো লিভ ইট লাইক দিস, এরকম আছে থাক। A2 is greater than A3 and therefore we take a approximation over here. সেজন্য আমরা এখানে একটা approximation নিচ্ছি। So that is why we take a approximation that A2 is nearly the average of A1 and A3. A2 is nearly the average of A1 and A3. A1 টা বড় আছে, A3 টা ছোট আছে, ভালো করে ভাবো, think carefully. A1 is greater than A2 and A3 is lesser than A3. মানে this term is greater and this time is lesser. So we say that the combination of these two togetherly gives you some average. So এই দুটোর অ্যাভারেজ এখান থেকে আমি পাচ্ছি, মানে as if একটা হচ্ছে 5, one is 5 and another is 3, that is one is, you say that the actual term is 4, ধরে নাও actual, just for idea, হ্যাঁ just আইডিয়ার জন্য বলছি, ধরে নাও 4 হচ্ছে তোমার বেসিক টার্মটা, 4 is the basic term, so 5 is greater than 4 and 3 is lesser than 4 and you take the average of it. মানে একজন 4 এর থেকে বড়, something is greater than 4, something is lesser than 4 and you take the average, you get it to be what? You get the term 4. So that is what I am trying to put it over here, right? And this is approximately, I don't say it truly because this relation is not true. A1 is greater and A3 is lesser with respect to A2. ভালো করে ভাবো, A1 is greater and A3 is lesser with respect to A2. So I take A2 to be somehow average of these two values. And similarly A4 টাও তাই, A4 also you can take it in this way. So some A3 and A5 you can take it like this, right? And so on. Average কিন্তু তাহলে আমরা কি লিখতে পারি? So you see that this the term within the parenthesis gets cancelled. সেটাই লেখো, therefore the term within parenthesis get cancelled. Parenthesis মানে actually what you call the first bracket. The term within parenthesis gets cancelled. Gets cancelled. The term within parenthesis, মানে এই যে এটা এই যে দেখো না এখানে, just have a look, A1 plus A3 by 2 is equals to A2, so that gets cancelled. মানে this one and this one togetherly makes what? A2. So and A2 and A2 gets cancelled. And similar things happens for all the terms. Okay, so what you are finally left with, তাহলে finally আমার কাছে কি থাকে? So therefore you will have A is equals to A1 by 2 will be definitely present if you have odd number of terms. Suppose you have odd terms, 5টা ধরো টার্ম ছিল, এইটুকুই ধরো টার্ম আছে, there is nothing after this, এরপরে আর কিছু নেই, A5 is my last term, okay, odd terms. So then at the last I have AN by 2. So at the last I have AN by 2. What the idea? বুঝেছো রে কি বললাম? লাস্ট টার্মে যে এটাই A5 by 2, ঠিক আছে না? আচ্ছা এখানে একটা জিনিস ভুল করেছি, A5 by 2 এর পরের টার্মটা কি হবে আরেকটা লিখে রাখি, -A6 হতো তাই না? If I have written this term, you people please also incorporate, তো তোমরাও লাগাও এখানে এই টার্মটা, -A6 হতো পরের টার্মটা if it was present, right? So this is the case if n is odd. So n যদি odd হয় তাহলে এটা হবে, কোনো অসুবিধা নেই, আর এটাই হয়ে যাবে, this one will become A1 by 2. আর দেখো যদি ইভেন নাম্বার অফ টার্মস থাকে, ধরো 6টা up to 6, so this and this will get cancelled, so what will be remaining? তাহলে থাকবে কি তোমার কাছে, brackets get cancelled, তাহলে কি আছে তোমার কাছে, last term is what? A6, that is your last term. So this will be something like this, you compare with that, an minus 1 by 2 minus an if n is even. এই ভালো করে কম্পেয়ার করে নাও, বুঝে যাবে, simple to understand. যদি তোমার কাছে যদি odd number of terms থাকে, if you have odd number of terms, that is suppose 5 terms, so you will end up at 5, তাহলে তোমার 5 এ শেষ করবে, 5 is n actually, you have n number of terms and in this case it is 5, suppose ধরে নাও, so the last term is an by 2. And if you have even number of terms, যদি জোড় সংখ্যা থাকে, if you have even number of terms, suppose it is A6, suppose it is A6, so who plays the role of n? n এর রোলটা কে প্লে করে? The last one, 6 plays the role. So that is why I have written, instead of A6 I have written minus an, and this one I have written an minus 1. So this 5 I have written an minus 1. Okay, so that's it. So this is how you get the things. But again you see that these issues are not at all an issue. এই ঘটনাগুলো কোনো ঘটনাই না এখানেতে, because final things are rather simple. You see that an means এখানে কিন্তু n মানে কিন্তু huge, so here n is huge, some 500,000 like that, and the contribution is so small. Contribution is so small because you see that your f theta n tends to what? F theta n finally tends to a minimum value, right? And that can be approximated to 0. এই বলেছো তো f theta n, আমি কি বলেছি, as n is increasing, as is increasing, theta is increasing, f theta is what? F theta is decreasing, and hence the amplitude is decreasing and going towards 0. So these terms are effectively, you can take it to be 0. এগুলোকে তুমি 0 নিয়ে নিতে পারো safely, কোনো অসুবিধা নেই, you can take them to be 0. If you calculate in reality, you will find them to be very small in comparison to A1. মানে ধরো A1 এর value 0.5, the value of A1 is 0.5, and the value of AN suppose and the value of an you suppose it is some 10 to the power minus 5, তাহলে কি করবে, নেগলেক্টিভ করবে, 0.5 প্লাস 0.0001 লাইক দিস, তো কি হবে, কিছুই হবে না। So it's negligible, so it's negligible in comparison to that, okay, because for a wave front these an are something a500 a1000 like that, so a500 1000 এই রেঞ্জে আসে, even if it is 100 also, no, it's also very negligible, 100 আসলেও negligible হবে। I will show you a problem. To overcome all these difficulties I have designed a problem, আমি একটা প্রবলেম ডিজাইন করেছি যেটা তোমাদেরকে দেখাবো। আমি ডিজাইন মানে I have selected the problem and I don't claim that I have made the problem, আমি বানাইনি, so I have selected from some textbook and I have modified it according to my requirements, তারপর আমি একটু modify করেছি a few of the values such that you get some proper idea for your better understandings। এই তাহলে এটা হচ্ছে অ্যামপ্লিটিউড, হ্যাঁ, অড নাম্বার অফ টার্ম থাকলে এটা, ইভেন নাম্বার অফ টার্ম থাকলে এটা। এবার তোমার কাছে যদি 200টা টার্ম থাকে, ইফ देयर আর 200 টার্মস, তাহলে কি অড ইভেনটা কি খুব ম্যাটার করবে? উইল দ্য লাস্ট টার্ম ম্যাটার ওভার হিয়ার? ভেরি স্মল লাস্ট টার্মস উইল ইট ম্যাটার? ইফ দ্য ভ্যালু অফ n is 200 300, it is not at all going to matter, কোনোভাবেই ম্যাটার করবে না, ঠিক আছে। ইন জেনারেল n is very large and we take it to be, in general n is very large, in general n is very large, and so this a we approximately take it to be, this a we approximately take it to be a1 by 2. These terms are negligible small, these terms are negligible small, right? কেন এটা হলো? এটা হলো তার কারণ হচ্ছে an or an minus 1, these terms you can take it to be 0 for smallness in obliquity factor, for smallness in obliquity, বলে দেওয়া ভালো না কেন এটা করছো, for smallness in obliquity factor, so an minus 1 এগুলো 0 হয়ে যাবে for smallness in obliquity factor, okay। So basically whatever you have is that the amplitude is due to half of the first half period chun, the amplitude is half of the first half period chun। তাহলে এবার তোমাকে আমি কোশ্চেন করছি, নাও I ask you a question, where does the other contribution goes? বাকি কন্ট্রিবিউশন গুলো কোথায় গেল? where does the other contribution goes? বলো বাকি কন্ট্রিবিউশন কোথায় গেল? a2 a3 a4, where are those? Even you don't get the first half period zone also, প্রথম হাফ পিরিয়ড জোনের কন্ট্রিবিউশন হচ্ছে a1, the contribution from first half period zone is a1, which also you don't get, the contribution from the first half period zone is a1, which you also don't get, তাই না? প্রথম হাফ পিরিয়ড জোনের কন্ট্রিবিউশন হচ্ছে a1, যেটাও তুমি পাচ্ছ না, কোথায় গেল এরা? where does it go? They have been interfered destructively, তাদের মধ্যে destructive interference হয়েছে, there has been destructive interference, some of them meet in same phase, some of them meet in opposite phase, বুঝেছো কথা? কয়েকটা ওয়েভ সেম ফেজে মিট করেছে, কয়েকজন অপোজিট ফেজে মিট করেছে, a1 a3 a5 met in same phase, but a2 a4 a6 met in opposite phase, and that is why there has been mutual cancellation that has reduced the amplitude even lesser than the first zone, first জোনের যে amplitude তার থেকেও কমিয়ে দিয়েছে এটা, even you didn't get the first zone completely, why? Because there has been cancellations over here, so that is what is a beautiful result that has been obtained by this Fresnel's approximation, but the beauty is still to come, এখনো বিউটি পুরোপুরি আসেনি, বিউটি দেখানোর বাকি আছে, আরো দেখাচ্ছি, ধৈর্য ধরো, আগে এটা লিখে নি, let me write the conclusion। Thus the amplitude due to the entire wavefront, thus the amplitude due to the entire wavefront at a point capital P, thus the amplitude due to the entire wavefront at a point capital P in front of it, at a point capital P in front of it is just due to the half of the contribution, is just due to half of the contribution, is just half of the contribution from the first half of the contribution from the first half period, right? Other contributions get mutually cancelled out due to interference effect. Now why people will believe you? Why people will believe Fresnel? So মানুষ Fresnelকে কেন বিশ্বাস করবে? So therefore the final intensity at the point capital P due to the entire wavefront is A1 square by 4. তাহলে গোটাটার জন্য এখানে আসবে হচ্ছে A1 square by 4. You will have some A1 square by 4. Now why will people believe Fresnel? কেন মানুষ Fresnelকে বিশ্বাস করবে? Fresnel বিশ্বাস করার মতনই কাজ করেছে. The task of the whatever he has said are believable. So that's why people will believe you and accept his results. Let me show you a game over here. তোমাকে আমি একটা প্লে দেখাই তোমাকে. So let me show you something interesting over here. Okay, interesting জিনিস তোমায় দেখাচ্ছি একটা. Let me think over it. Okay, এক মিনিট দাও একটু ভেবে নি. So what do I actually, because this is from my intuition, so let me think over it. I don't have ready-made this one. Just let me think. Okay, এরকম ভাবো তুমি যে তোমার এখানে তো অনেকগুলো জোন আছে. You have many number of zones over here. Suppose you have many number of zones. Okay, there are many number of zones. ঠিক আছে, there are many number of zones in the wavefront. This wavefront you allow it to incident. This wavefront you allow it to be incident. Where you allow it to be incident on a circular aperture. Diffraction in circular aperture. এইটাকে তুমি সার্কুলার অ্যাপারচারে ফেলে দাও. সাপোজ দিস ওয়ান ইজ ইউর সার্কুলার অ্যাপারচার, দিস ওয়ান ইজ ইউর সার্কুলার অ্যাপারচার. ইউ ইনসিডেন্ট দিস ওয়েভ ফ্রন্ট ওভার দিস. এই ওয়েভ ফ্রন্টটাকে সার্কুলার অ্যাপারচারে ফেলে দাও. ইউ পুট ইট অন দিস সার্কুলার অ্যাপারচার, রাইট? নাও হোয়াট উইল হ্যাপেন ইজ দ্যাট the wavefront will be obstructed. Maximum part of the wavefront will be obstructed and you allow only the first half period zone to be within the aperture. এমন কিছু একটা করো যাতে গোটা ওয়েভফ্রন্টটা তোমার এখানে অবস্ট্রাক্টেড হয়ে যাবে. The entire wavefront will be obstructed, right? So this one will be the entire wavefront. So you see that the wavefront will be obstructed. So these waves you see they are obstructed. এরা কিন্তু পাস করতে পারবে না. This half period zone cannot pass. So you just choose the aperture in such a manner. তুমি অ্যাপারচারটা এমন ভাবে চয়েস করো, you choose this aperture in such a manner, very small aperture, such that only the first half period zone can pass through this. শুধুমাত্র প্রথম হাফ পিরিয়ড জোনটা পাস করবে, বাকিগুলো পাস করবে না. এই কথা বুঝেছো? Only the first half period zone will pass and the others will not pass, right? If the others will not pass, so the contribution at the point capital P, তাহলে P পয়েন্টে কন্ট্রিবিউশনটা শুধুমাত্র কার জন্য আসবে? So the contribution at the point capital P will be due to whom? Try to answer now. The contribution at capital P will be due to whom? Capital P point a contribution তুমি কার জন্য পাবে? So you will get the contribution at capital P due to whom? Only because of the first half period zone. And as it is because of the first half period zone, so now your contribution at the point capital P IP dash I call it. So that one will be definitely A1 square. বুঝেছো তো? What is the amplitude of the first half period zone? The amplitude of the first half period zone is A1. Only A1 is passing. বাকিগুলো নেই এখানে. The others are not present. Only A1 will be able to pass. The others will not be able to pass. এই যে খালি A1 টা পাস করবে, বাকিগুলো পাস করবে না. Only A1 will pass over here. So what will be the amplitude? A1 and intensity is A1 squared. And this has been found in reality. এইটা মানুষ বাস্তবে পেয়েছিল. And that is why people believed Fresnel. The intensity has increased 4 times. Just look at the expression. Can I say that IP dash is 4 times of IP? তার মানে point P তে যে এফেক্টটা, the effect at the point P have increased 4 times once you introduced a slit in the path of it. See how beautiful it is. How beautiful. You just think it. Just ভাবো. আমাদের common sense কি বলে? Our common sense says that if I block the light, আমি যদি লাইটটা ব্লক করে দিই, if I block the light, so then I will get lesser intensity. But here the situation is completely different. Once you block the light, Once you block the light, you get more intensity at the point P. See what beautiful. See, খালি ভাবো এরা কি করেছে এই মানুষগুলো। Just think about them. What they have done with the piece of a just with a piece of paper and their pen. কি কাজ করেছে এরা। তুমি যখন ব্লক করছো লাইটের ইন্টেন্সিটি 4 টাইমস বেড়ে যাচ্ছে, দ্য ইন্টেন্সিটি ইজ ইনক্রিজিং 4 টাইমস, এন্ড দিস হ্যাপেন্ড ইন রিয়েলিটি। এইটা বাস্তবে হয়েছিল, এন্ড দ্যাট ইজ ওয়াই পিপল হ্যাভ বিলিভড these three assumptions. এই জন্য মানুষ এটা বিলিভ করেছে that really there are zones. ভাবতে পারছো যে কিভাবে এরা এনেছে, how did they bring the concept half period zone out of nothing he introduced the concept of half period zone. এবং এখন বলছে যে তুমি এমন ভাবে স্লিট উইথটা অ্যাডজাস্ট করো, you adjust the slit width in such a way that only the first half period zone passes, and then you see that the intensity increases like that. And then he says, বসে নেই, and then he says that now you do, এবার বলছে যে এইবার যেটা করবে তুমি সেটা হচ্ছে he has increased the slit width, স্লিটের উইথটা বাড়াচ্ছে, বলছে চলো একটু স্লিটের উইথটা বাড়িয়ে দিই একটুখানি অল্প করে, স্লিটের উইথটা বাড়াই, ঠিক আছে চলো স্লিটের উইথ বাড়ানো গেল, increased in such a manner such that the second half period zone enters over here, এমন ভাবে বাড়ালো যাতে সেকেন্ড হাফ পিরিয়ড জোনটাও ঢুকে গেল। So now you have two zones. এখন তোমার কাছে কটা জোন আছে? How many zones? You have two zones. And now you see that the intensity at P decreases. Beautiful. তুমি যত বেশি তুমি জোন, তুমি মানে স্লিট উইথ, তুমি স্লিটটাকে ওপেন করছো, as you are opening the slits, তুমি স্লিট ওপেন করছো, the intensity decreases. Just you look at the beauty. So P point intensity টা কমে গেল কেন? Because A1 is positive, but now A2 also comes into the picture. Picture A2 চলে আসে, and A1 minus A2 will be diminished, and it will be nearly zero, because A1 and A2s are nearly equal. A1 A2 গুলো মোটামুটি ইকুয়াল তুমি ধরতে পারো, because A1 A2 খুব কাছাকাছি আছে, A1 and A2s are nearly close. Obviously A1 is somehow greater, nearly, চলো ধরি না nearly equal, তাই না, nearly zero, আর জিরো না হোক ভাই, কমছে, এটা হচ্ছে বেশি ইম্পর্টেন্ট। তুমি যদি ব্লক না করো, if you don't block the wave front, you have A1 square by 4 as the intensity. You block the wave front and allow only the first one, শুধু প্রথমটাকে তুমি পাস করতে দাও, you get 4 times of the initial intensity. Now you allow another zone to pass, আরেকটা জোনকে পাস করাতে দাও, সঙ্গে সঙ্গে তুমি দেখবে once you allow another zone to pass, you will see what, সঙ্গে সঙ্গে দেখবে ইন্টেন্সিটিটা ড্রপ করেছে। Now this can be also done by varying the position of the P. সেই P পয়েন্টের পজিশন চেঞ্জ করেও তুমি কিন্তু এটা ভ্যারি করতে পারো, you can vary the intensities. Why? Because you know that the radius of the zone, মানে how many zones will pass over here, the radius is basically given by what, the radius are basically given by you know it, that root over radius এর কত যেন ফর্মুলাটা ছিল, I forgot it. There is definitely some P dependence, radius এর মধ্যে P dependence আছে কোথাও একটা, এই যে এইটা, the radius of the zone, that is L lambda P. The radius has some dependence on P, L lambda P, তাই না, L lambda P. The radius has some P dependence, L lambda P. So if you change this distance P, তুমি যদি distance P টা চেঞ্জ করো, so then also the radius of the half period zones will be changing. মানে এই স্টাডিটা এরকম ভাবে হতে পারে, you keep the slit width constant, and then you vary the position of the point P. P পয়েন্টটাকে তুমি আগে পিছে করতে পারো, you can take the point P nearer, further, you can do it. So and that will decide the radius of the zones. So how many zones, that will give you the radius of the zones, তাই না, তুমি এখান থেকে জোনের রেডিয়াসটা পেয়ে যাবে, and that will show you that how many zones are over there. So এখানে কতগুলো জোন আছে সেটা তুমি বুঝতে পারবে। So that is how you will understand that how many zones can pass through this. So কতগুলো জোন এখান দিয়ে পাস করবে সেটা বোঝা যেতে পারে, you can get an idea of that. Okay, মানে ধরে নাও এইটা রেডিয়াসটা ক্যাপিটাল আর, so this radius, you see that this radius is capital R. So within a radius of capital R, how many small r's are accommodable? So একটা ক্যাপিটাল আর রেডিয়াসের মধ্যে কতগুলো স্মল আর কে আমরা অ্যাকোমোডেট করতে পারি, so how many small r's can we accommodate over here, right? So that is what we can calculate definitely from here. Okay, so how many zones can be accommodated? So you can either increase the slit width or you can change the position of the P. Position P is quite confusing, so better to explain by increasing the slit widths. ঠিক আছে, বুঝেছো তো? তার মানে যখন কিছু স্লিট ছিল না, it was some IP, you allow one half period zone to pass, you block everything and allow one of them to pass. the intensity increases, you allow another one to pass, the intensity decreases. So this actually shows ওই যে ফ্রেনেলের কথাটা, the secondary waves interfere among themselves. It is really interference, সত্যি interference, সেই কারণেই তো কমে যাচ্ছে. Why it is decreasing? When you are allowing only one half period to pass, যখন একটা হাফ পিরিয়ড জোনকে তুমি পাস করাচ্ছ, when you are allowing only one half period zone to pass, you are allowing only one half period zone to pass, you see that there is no interference, the maximum passes, and that is why you get the maximum intensity. And next, when you allow another half period zone to pass, যখন আরেকটাকে পাস করাতে দিচ্ছ, and that one is in the opposite phase, a1 and a2 are pi phase different. Look at the idea, কি সুন্দর বানিয়েছে, opposite phase half period zones বানিয়েছে, opposite. So a1 and a2 is negative, so that means that there is an interference, destructive interference, and that is why you see that there is no light, or the light is decreased. So destructive interference হয়েছে, right? So এই হচ্ছে স্টোরিটা, দিস ইজ দ্য থিং ইজ গোয়িং অন. তাহলে ওই যে ফ্রেনেলের যে কথাটা, হোয়াট এভার ফ্রেনেল হ্যাজ সেড, again all the points are the sources of secondary disturbance. ফ্রেনেল কি বলছে, these secondary disturbances interfere among themselves, and that has been clarified by observing at P, এবং সেটাই P পয়েন্টে অবজার্ভ করে পাওয়া গেছে. And that interference has been shown from the concepts of the half period zones. So each of the half period zones acts as a source, and you see that all the sources are coming from the same wavefront, and this is what is diffraction. That interference of the waves coming from the same wavefront, that is what is diffraction. সেটাই এখানে হচ্ছে. So diffraction এখানে তো হয়েছে, that is the interference of the secondary wavelets, that is what is diffraction, and that effects can be manifested very easily when you have some obstacle or when you have some aperture. যখন কোনো অ্যাপারচার বা অবস্টাকল থাকে, তখন এই জিনিসটা আরো সুন্দর করে বোঝা যায়, you can understand the things in a better manner. Okay, so I hope that you are getting the things. তুমি নিশ্চয়ই ব্যাপারগুলো বুঝতে পারছো আমি কি বলতে চাইছি. So try to study them, try to understand them. Let me show you another interesting thing. আর একটা জিনিস দেখাই রে, এবার obstacle, হ্যাঁ obstacle. Suppose I put some obstacle over here. So there are many half period zones. This is the first one, second one, third one. এরকম ভাবে তোমার zones গুলো আছে, and then some other zones also at a large distance. Suppose I block the first one. So এমন কিছু একটা করলাম যাতে প্রথমটা ব্লক হয়ে গেল, হ্যাঁ. So this one is the case, okay. এখানে ব্লক হয়ে যায়. This one is the block that I put over here. So এটা হচ্ছে ব্লকেজটা. This one is the blockage that I put over here, okay. Some circular blockage I put, আমি এটা সার্কুলার ব্লকেজ দিলাম এখানে, I put a circular blockage over here such that the first half period zone don't pass. এমন একটা ব্লকেজ দিলাম যাতে প্রথম হাফ পিরিয়ড জোনটা না পৌঁছাতে পারে পিঠে, such that the first half period zone doesn't pass. What was the last case? Last case কি বলেছিলাম, you do such things that only first zone will pass. এমন কিছু করো যাতে প্রথমটাই পাস করবে, do something such that the first zone will pass and the others are blocked, and now others will pass but the first will be blocked. প্রথমটা ব্লক হয়ে যাবে, ঠিক. তাহলে এখন পি পয়েন্টে ইন্টেন্সিটি কত আসবে, দ্যাট উইল বি সাম a2 স্কয়ার বাই 4. আরে সোজা রে, প্রথমবার কি ছিল, ফার্স্ট ওয়ান when you allow all of them it was a1 by 2, and now you allow from which zone, you start from a2. এবার তুমি a2 থেকে স্টার্ট করছো, you start from a2, right? So what will be the amplitude? তাহলে অ্যামপ্লিটিউডটা কি হবে, instead of a1 by 2, because a1 is blocked, a1 কে ব্লক করেছি আমি এখানে, এটা হচ্ছে তোমার কি, এটা অ্যাপারচার না, this one is the obstacle. একটা ডিস্ক ধরো বসিয়ে যাই, পুটে ডিস্ক ওভার হিয়ার, অবস্টাকেল লাগিয়েছি. তাহলে অবস্টাকেল কি বলছে আমাকে, হোয়াট ডাজ দ্য অবস্টাকেল সে, দ্য অবস্টাকেল সেজ দ্যাট দ্য লাইট ক্যানট পাস. হুইচ ক্যানট পাস, দ্য ফার্স্ট জোন ক্যানট পাস, এই জোনটাকে অ্যালাউ করছি না. তাহলে a1 যাবে না, a1 উইল নট পাস. তাহলে কোথা থেকে স্টার্ট হবে, হোয়ার ফ্রম উইল ইট স্টার্ট, ইট স্টার্ট ফ্রম a2, and then there will be mutual interferences. So the amplitude at the point P is how much, it is a2 square by 4, right? a2 square by 4, তার মানে কি হলো, ডিক্রিজ করলো তো. So the amplitude decreases. কেন ডিক্রিজ করলো, because of the obstacle the amplitude decreases. obstacle দিয়েছো, amplitudeটা ডিক্রিজ করলো. এইবার obstacle-এর সাইজ বাড়াও, increase the size of the obstacle. বা তুমি এরকমও করতে পারো, obstacle-টাকে আরেকটু কাছে নিয়ে আসো, you bring the obstacle closer. If you bring the obstacle closer, so then the radius of the disc will decreasing. So radiusটা কমে যাবে, and more will be obstacle, এবং বাকিরাও এখানে obstacle হয়ে যাবে, বাকিরাও obstacle হয়ে যাবে. হ্যাঁ, তোমাকে মনে রাখতে হবে যে তুমি দুভাবে জোন আটকাতে পারো, you can block in two ways. One of the way is to move the point of observation. Point of observation move করো, বা তুমি এই পজিশন, so you just move the positions, এটা একটা হতে পারে. which is difficult to understand, we don't go to it. So আমি যেটা করছি, I am increasing the size of my obstacle. This is easier for you to visualize. এটা visualize করা সুবিধাজনক। ধরে নাও তাহলে সেকেন্ডটাও ব্লক হয়ে গেল, the second one is also blocked, second is blocked, ঠিক আছে? তাহলে বাইরে কোনটা যাবে? who will come at the outside? So A2 is blocked, so you will have A3 square by 4. And if you go on increasing the size of the obstacle, যদি এর সাইজ যদি বাড়াতে থাকো, if you try to increase, so at a time you will have only an square by 4. That means it will be corresponding to 0, right? Do you understand that P point is the shadow region? তুমি কি বুঝতে পারো P পয়েন্টটা হচ্ছে শ্যাডো রিজন? এটা তো ডিস্কটা, this one is your disk, so this P point is definitely within the shadow of it, and you see that the light within the shadow is gradually decreasing. ভালো করে চিন্তা করো, you think it. When you put the obstacle such that the first half period zone is blocked, এমন ভাবে obstacle রাখলে যে প্রথম জোনটা ব্লক হলো, then the light definitely decreases from A1 by 2 to A2 by 2 or A2 square by 4. Then you increase the size of the obstacle, so then the light at the point P that is within the shadow region is A3 square by 4. And finally, if you block many number of zones such that only an square by 4 is allowed, শুধুমাত্র an square by 4 তুমি ওখান দিয়ে পাস করাচ্ছ, and then you see over here that there is no shadow within the, there is no light within the shadow region. তাহলে তুমি দেখো শ্যাডোতে কিন্তু কোনো লাইট যাচ্ছে না, so there is no light within the shadow region. Do you get it? So this actually shows that diffraction will occur only when the size of the obstacle is small. So এখান থেকে এটাও বোঝা যাচ্ছে that এই যে শ্যাডোর মধ্যে লাইট ঢুকে যাওয়া, the light entered within the shadow. So this is what is the phenomena of diffraction, that light entered within the shadow. So this is diffraction, this is due to the mutual interferences. So this effect occurs when the size of the obstacle is small. অবস্টাকেলের সাইজ যখন স্মল আছে তখনই কিন্তু এই ঘটনাটা ঘটে, that light enters within the shadow. If you increase the size of the obstacle, so this phenomena gradually decreases. বুঝতে পারছো এখন কেন আমরা বলি, why do we say that for diffraction the size of the obstacle should be small and comparable to the wavelength? That size should be small, right? So এই হচ্ছে সাইজের ব্যাপার, এখান থেকে আসে. So that is how you get the size, ঠিক আছে? আর সাইজটা কেন বলি comparable? Because this size should be comparable with these half period zones. And what is the radius of a half period zone? The radius of a half period zone you see, that is again dependent upon some lambda. So এটা কিন্তু আবার একটা ল্যামডার উপরে কিন্তু এর একটা ডিপেন্ডেন্স আছে. There is a dependence over here on this particular lambda. So lambda dependence থাকার জন্য, so because of this particular lambda dependence, okay, so we say it to be of that particular dimension. So সেই ডাইমেনশনে যেতে হয়, because you see that this r, এই যে r গুলো, so this r will be very small, r গুলো very small হবে. This p, you suppose it is 1 meter, so এটা তুমি ধরেও নাও যে 1 মিটার ডাইমেনশনে আছে, but this lambda is of the order of 10 to the power minus 10 meter. আর এই n টাকে তুমি ধরেই নাও, so this n also you take it to be some 100, এখানে যদি 100 নাও, so then also the net order will be of the order of 10 to the power minus 8 বা something like that. The root over আছে যদিও, but it's very small. So the idea is that the things are going to be very small. Okay, so that's why we say comparable to the dimension of wavelength. So wavelength has a role to play. এই যে কেন যে বলি that why it is dependent on wavelength, because you see that this half period zones has some dependence on the wavelength also. And you see that the first line of my class, today's class, আমি লিখেছি we consider a wavefront corresponding to wavelength lambda. So wavelength তাও কিন্তু যথেষ্ট গুরুত্বপূর্ণ. So not only wavefront and half period zones, which lambdas you are using, that is also very important. Okay, so that's why lambda dependence. তাহলে এখান থেকে বুঝলে that why smaller obstacles, smallness is required to observe diffraction. So কেন smallness দরকার diffraction-এর জন্য সেটা আশা করি তোমরা বুঝলে, that why smallness is required to have the diffraction. And this also explains the rectilinear propagation of light. এবং এখান থেকে rectilinear propagation actually দেখো মানুষ ভেবেছিল, so দেখো তুমি এখানটাতে তুমি একটা obstacle রাখছো, so you put an obstacle over here, you see that you put an obstacle over here, so and you allow some source from here, so এখান থেকে একটা source allow করেছো, so light will just pass on like this from this point source. Okay, এইভাবে লাইটটা পাস করবে, so the light will pass and within this region you expect that there is no light, এবং এইটুকু জায়গায় কিন্তু কোনো লাইট থাকবে না. At the point this capital P, the midpoint of this disk, এই midpoint-এ কোনো লাইট কিন্তু থাকার কথা নয়. There should not be presence of any light if you don't consider diffraction. But once you consider diffraction, that is the presence of the half period zones over here, and then light can enter from these zones. তাহলে তখন জোন থেকে লাইট এখানেতে আসছে, তাই তো? From the zones the light enters over here. So that's the idea over here. So basically people during that 17th century, before the discovery of this wave theory of light, wave theory Huygens principle, so তো মানুষ মনে করতো, পিপল ইউজ টু থিঙ্ক, ও শ্যাডোর ভেতর লাইট এসছে, লাইট এন্টার দ্য শ্যাডো, তার মানে এইখান থেকে লাইট হ্যাজ ট্রাভেলড in a bended path, in a bent path. So light has traveled in a bent path, right? So rectilinear propagation was thought to be wrong. So মানুষ ভাবছিল যে লাইট তার মানে স্ট্রেট লাইনে যায় না রে, the light doesn't goes in the straight line. This is the obstacle. Obstacle এর শ্যাডোতে লাইট কি করে ঢুকতে পারে? How light can enter within the shadow of the obstacle? That means তার মানে লাইট এখানে হিট করেছে, light has hit over here and then ওর পাথ বেঁকে গেছে, it has bent down. It has bent down over here, and similar for the aperture case also. So aperture তাই, in the aperture also you see that the for point source there should not be no light in the, you see that there should be no light beyond this point. এই পয়েন্টের বাইরে কিন্তু লাইট থাকা উচিত না, beyond this point and beyond this point, এখানে এই পয়েন্টটা, there should not be any light. Okay, there should not be any light over here because these are the shadow regions. But interestingly you find light over here. So এখানে লাইট যায়, কেন যায়? ওই যে half period zones, the light actually goes from the zone, এর জোন থেকে লাইট গিয়ে ওখানে হিট করেছে, the light has hit over there, and that is what is diffraction. সেটা ডিফ্রাকশন, ঠিক আছে? তাহলে রেক্টিলিনিয়ার প্রপাগেশন অফ লাইট ইজ ট্রু, লাইট স্ট্রেট পথেই যায়, কিন্তু এখানে কারণটা অন্য। ইট ইজ নট দ্য বেন্ডিং অফ লাইট, লাইটের পাথ বেঁকে গেছে তা নয়, লাইট ডিড নট বেন্ড, লাইট বেঁকে গিয়ে পি পয়েন্টে ঢুকেছে তা নয়, এটা অবস্টাকেল ভেবো না এটা, ডোন্ট থিঙ্ক দ্যাট দিস ইজ দ্য সোর্স অফ লাইট, দিস ইজ দ্য সোর্স, লাইট হ্যাজ ট্রাভেলড ওভার হিয়ার, এখানে অবধি ট্রাভেল করলো, তারপরে বেন্ড হয়ে গেল, ইট হ্যাজ বেন্ডেড, নো ইট ডিডন্ট বেন্ড, ইট ডিডন্ট বেন্ড, তো বেন্ড হয়নি এখানেতে, ইট হ্যাজ আন্ডারগন ডিফ্রাকশন, it has undergone diffraction over here, and that is the diffraction is what? Diffraction is the mutual interference of the wavelets. So wavelets এর যে interference সেটা p পয়েন্টে দেখা যাচ্ছে, that is what you find at the point p. Okay, okay, and that has been explained by this way, যে obstacle করে করে, so this obstacle, so এখানে বলছে as you are increasing the size of the obstacle you see that the intensity is decreasing. Had light has traveled in a bent path, so then the intensity shouldn't have decreased. Light যদি ব্যাক পথে যেত তাহলে অবস্টাকেলের সাইজ আমি যাই করি না কেন, whatever be the size of the obstacle, suppose I make the size of the obstacle very big, আরো বড় করলাম অবস্টাকেলের সাইজ, I make the size of the obstacle like this, so lighter কি আছে এখান অবধি যাবে, it will go up to this and then it will bend, right? Again I make it bigger, আরো বড় করছি, লাইট বলবে হ্যাঁ যাবো রে ভাই, এখান অবধি যাবো, up to here I will go in straight line, and আমার তো আছেই, আমি দেখবো, I will bend over here, light will say like that, and I will reach point P. But you see that as you are increasing the size of the obstacle, the intensity at P is gradually decreasing. As you are increasing the size of the obstacle, I repeat, as you are increasing the size of the obstacle, the intensity at the point P is decreasing. So that means that light actually travels in straight path. What actually happens is that it is the diffraction. তাই না? কেন লাইট যদি ব্যাক পথে যেত, if the path was bent, তাহলে ওর কি তুমি সাইজ যাই করো না কেন, whatever be the size, it will bend across the ends, ও বেন্ড করে ঢুকে যাবে, it will bend and enter over here, right? But that doesn't happen, right? So সেটা তো হয় না, as you are increasing the obstacle, so then diffraction is diminishing, diffraction phenomena কমে যাচ্ছে আস্তে আস্তে, the effect of diffraction is diminishing, and that is why at the point P at a time you will see that there is no light. And this confirms that light doesn't travel in bent path. Light rectilinear hi ache, light travels in a straight line path only, but you see some light on the shadow of the light ঢোকে, not due to bending, the light enters within the shadow not due to bending. ওই জন্য দেখবি on the first class I have said apparent bending, আমাদের মনে হচ্ছে যেন bending, apparent, আপাতদৃষ্ট, apparently it appears to be bending, but it is not the true bending, it is the phenomena of diffraction. So whatever is happening is diffraction, not bending. Okay, so proper আমি এখানেতে তোমাকে, so I have taken the note from some book, I will just borrow it and paste over here. So আমি নোটটা দিয়ে দিচ্ছি, such that you people can study it properly, যাতে তোমাদের পড়াশোনাটা সুবিধাভাবে করতে পারো, আমি নোট দিয়ে দিচ্ছি, I am providing you the note. The note is this one. Yes, the explanation of rectilinear propagation of light. So I have collected it from a very standard book which I found to be the best available for you people. Just এটা একটু পড়ে নেবে, just you read it yourself, you will understand. So whatever I have said, that is over there. So আমি যা যা বলেছি সেটাই ওখানে আছে, নিজেরা পড়ে নেবে। আরেকটা জিনিস পড়তে হবে, this is just for your interest. leave it, I will paste over here. Diffraction by circular aperture. So this is what I have taken from that book of Ajay Ghatak. So এটা অজয় ঘটকের বই থেকে আমি নিয়েছি. If you have the book, you may read from there only. So diffraction by circular aperture. So the story that I have said over here, so that story is written in a concise form. So যেই স্টোরিটার কথা আমি বলেছিলাম সেটা এখানে concise ফর্মে লেখা আছে, ঠিক আছে? Rectilinear propagation টা একবার দেখে নাও. So you just have a look at the rectilinear propagation. As the size of the half period zones are very small, a tiny obstacle is sufficient to cover a large number of zones by which light from the source is practically cut off. মানে as you are increasing the sizes, এই যে এখানে বলেছে, thus the illumination at P gradually diminishes and ultimately become too small when the size of the obstacle is large. When the size of the obstacle is large enough to intercept appreciable number of half period zones. মানে অনেকগুলো half period zones আমাদের ব্লক হয়ে গেছে, and then the light is actually cut off. So তখন মোটামুটি তখন the light is cut off, and this is interpreted as the rectilinear propagation of light, because if it was not a straight line path, so then তাহলে তো কমলো কেন? So why it is decreasing? So this phenomena actually gives you two ideas. একটা হচ্ছে diffraction should occur when the size of the obstacle is small. Obstacle এর size small হলে তবেই diffraction হবে, first idea. And the second idea is that rectilinear propagation of light. So rectilinear propagation of light ও কিন্তু সেখানে হতে হবে। আর এখানটাতে আমি যেটা বলেছি, here whatever I have said is that, so don't look at all this. So এইগুলো তুমি দেখে অত কাজ নেই, this figure number and all those. So figure number you can draw it yourself. Capital P is at a distance d. We assume that the radius is a, radius of the circular aperture is a, and can be increased. As a is increased, the intensity at point P would also increase till the circular aperture contains the half period zone. So first half period zone যখন থাকবে, what is the radius of the zone? দেখো radius of the zone আমরা বলেছিলাম, এখানে যেটা d বলেছে না সেটা আমাদের কাছে p. So d is actually p to us. So you just read it in that way. So এখানে যেটা d বলা হয়েছে আমাদের কাছে সেটা হচ্ছে p. So that is actually p, n lambda p. So half period zone. The resultant amplitude at capital P would be U1, which is, এটা U1 হবে না, এটা হয়ে যাবে A1 আমাদের জন্য, which is twice the value of the amplitude of the unobstructed wave. Unobstructed wave. So equation 12 মানে এখানে হচ্ছে এইটা. Equation 12 মানে A is equals to A1 by 2. এইটার কথা বলেছে, this equation. The intensity would be therefore 4I0. মানে যেখানে আমাদের I0 টা হচ্ছে A square, মানে হচ্ছে A1 square by 4. Right? So it will be 4I0. So it was A1 square by 4, but now it will be A1 square. তাই if we further increase A, আমি যদি A যদি আরো increase করি, then UP, এটা UP মানে actually A, the amplitude would start decreasing, and when contains first two half period zones, the resultant would be almost zero. এই যে A1 minus A2. A1 minus A2 would give almost zero. Thus increasing the whole diameter, the intensity at P almost reduces to zero. This interesting result is once again due to validity of the Huygens-Fresnel principle, and hence would be valid. Sound waves দরকার নেই, sound waves এর গল্প আমাদের নেই, এসব ছাড়ো, leave it. We may generalize the above result, noting that if A equals to these values, A এর ভ্যালু যদি এইগুলো হয়, 2n plus 1 into lambda by 2, 2n plus 1 into lambda by 2 মানে when the number of zones is 1, 3, এই সবগুলো. So if you use n equals to 1, you see that you will get what? Lambda d. If you use n equals to 0 use করলে lambda d পাবে. If you use n equals to 1, you see you get 3 lambda by d. 3 lambda by d মানে যে third half period. If you use n equals to 2, you get 5 lambda by d. That means 5. So whenever there is odd number of zones, odd number of half period zones, so there will be maxima at the point. কথাটা বুঝেছো তো? একটা half period zone হলে you get some light at P. If you have two half period zones, then their effects will be mutually cancelled, A1 minus A2. So the intensity will reduce. Okay, so if there are two half period zones, so the intensity will be reduced. So that condition is this. If you use n equals to 1, then you see you have 2 lambda by 2. 2 lambda by 2 মানে কি? The second half period zone. আবার 2 ইউজ করলে 4 lambda by 2. তার মানে যদি তোমার এখানে ইভেন নাম্বার অফ জোন যদি থাকে, that is 1, that is 2, so it will be A1 minus A2, it will be minima. Again, if there are 3 half period zones, 3টে half period zone থাকলে A1 minus A2 is minima, but you have additionally A3. কিন্তু সঙ্গে আমাদের কি আছে? আবার A3 আছে. A1 minus A2 is minima, I believe, but I have A3 also, and that A3 gives me what? এবং A3 টা আমাকে কি দেয়? A3 again gives some positive effect, so again it becomes a maximum. But definitely these maximas are of reducing intensity. কোন ম্যাক্সিমাটা সবথেকে বেশি? The first maxima occurs when this value of n is 0. মানে যখন শুধু একটা জোন খালি পাস করেছিল, only when one zone has passed. right? So these are the things that is going on over here. আর এখান থেকে দেখো একটা আইডিয়া দিয়েছে that what are the radius of these zones. So জোনের রেডিয়াসের একটা মোটামুটি আইডিয়া তোমাকে দেওয়া হয়েছে এখানেতে 0.5 মিলিমিটার, 0.5 millimeter is the idea. So that is what you obtain over here, right? So these are the things that I needed to discuss with you. So এই জিনিসগুলোই আমার তোমাদের সাথে ডিসকাস করার ছিল, and I hope that you have understood everything that actually what I wanted to discuss with you. So যা যা আমি ডিসকাস করতে চেয়েছিলাম সেটা আমি ডিসকাস করতে পেরেছি. I am happy with that, and I hope that you have also understood. So you just take, for better understanding, once you take circular aperture, better understanding এর জন্য একবার তুমি অ্যাপারচার নাও, আর একবার তুমি আরেকটা কি নিতে হবে, you take obstacle, আর একবার তুমি obstacle নাও. Once you take a circular aperture and you take a circular obstacle, and you can understand the things in a better way, right? So that is what about the Fresnel half period zones. And these half period zones, the concept can be extended for other geometries, which I am not going to do in this class. এই ক্লাসে আমি সেটা করছি না, but you can see that this half period zone concept can be extended to view the diffraction in many other geometries, such as a straight edge, such as the that slit also, one dimensional slit also you can use it. Slit ও করতে পারবে where the source is at finite distance, you can do it. And there is another, so there are other effects also, okay? So those everything are not included in your course, সবকিছু তোমাদের কোর্সে নেই. And as you are moving the sources and slit and the screen away, so then you will see that the Fresnel results will shift over the Fraunhofer result. মানে Fresnel result থেকেই তুমি দেখাতে পারবে যে আমরা Fraunhofer শিফট করে যাচ্ছি, we are moving towards the Fraunhofer result. You can show it. You just take the slit, একটা slit now, one dimensional slit, you study the Fresnel effects, and then you can increase the distances of the source and the screen to infinity, and then you will see that those will match up with the result that you have for the Fraunhofer diffractions. Just this is for your information, এটা শুধু ইনফরমেশনের জন্য বলছি, but these things can be done, okay? So just enjoy the beauty of the Fresnel's diffraction. Listen to my words again and again. After the calculation, whatever I have said, you listen to that again and again for your better understanding. Okay, I hope that you have gone through it properly, and now it's your turn to read some standard textbook. I repeat once again, standard textbook. Don't read bad books. বাজে বই পড়বে না. So read some standard textbooks. The references of all the standard textbook you will find at the end of your syllabus of each paper. প্রত্যেকটা পেপারের সিলেবাসের পরে দেখবে কিছু বইয়ের নাম দেওয়া আছে, some books are mentioned. So those are standard textbooks. So you may also consult with the teachers. With me you can consult. I will help you to find out the good books. সেই বইগুলো পড়বে, read those books.